Let's Science is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
So Caroline, you are going today to tell us about lightning crystals, also known as, is it Fulgurites? Did I say that right?
Fulgurites.
Excellent. Yeah. This sounds very exciting. So over to you. Let's go.
There's a new term for you. Fulgurites. It's also a new term for me because I didn't know what they were called before. So there we go. So I found this really interesting. First of all, because I didn't know much about it, and then anyway, I'll continue on, and then you'll know why as well. It's a very interesting topic. So there's been a never seen before mineral found in a fulgurite. A potentially brand new mineral may have been hiding inside a chunk of fossilized lightning from Florida, scientists have revealed. Researchers led by Matthew Pasek from the University of South Florida published their findings in the March 14 journal Communications, Earth and Environment. So far, this material has never been found to occur naturally on Earth. Research on this type of mineral was only recently performed on fulgurites, or crystals formed by lightning. Matthew Pasek, who is a geoscientist, said that the minerals that they have found are similar in composition to those found in meteorites in space, but they have never found this particular mineral anywhere here on Earth. So what exactly are they studying? They are studying the crystals called fulgurites. And they are often called, like you said, Lindsay, fossilized lightning or lightning crystals. They capture the pattern of lightning in sand, soil or rock, as well as organic material on the ground, and create a crystal fossil when the lightning hits. The soil, sand or rock or organic material fuses together after it's been hit by lightning to form a singular clump. They often look like hollow or branching structures of glassy tubes. They can be crusty or clumpy masses. Some of them look really metallic. Some will just look like rock. There's all sorts of amazing structures and physical properties to them. A very interesting fact of the fulgurites is they don't actually have a fixed composition because they're actually made up of the materials that the lightning makes contact with, which makes sense, yes. So this particular fossilized lightning clump that was being studied was created when lightning struck a tree near Port Richey, which is in Florida in the United States. Matthew Pasek, this researcher, purchased this particular fulgurite from the owner of the tree it was found near, and to study it further. His area of research really is to study high-energy chemical reactions such as those generated by lightning strikes. This fulgurite was around 2.8 inches, or that's 7 centimeters long, and 0.8 inches, or 2 centimeters wide. He and his fellow researchers discovered a colorful crystal-like matter within the fulgurite when they opened it up and examined it using an electron microscope. Further analysis revealed that the matter was previously unknown material consisting of mainly a calcium phosphate. It was suspected that this material is new and previously undiscovered. Further study by scientists will have to be performed to confirm this is true. So hopefully when the material is confirmed as a new material, it will be officially named. So, it'd be like something like, I don't know, there's all sorts of minerals that we have on Earth, like amethyst and, all those kind of pyrites, all sorts of different minerals. So this is a new one that they haven't found here on Earth yet. So during the research, the team actually tried to recreate this calcium phosphate mineral in the lab, but they were unsuccessful. It's believed that the reason is because it's usually formed rapidly in nature and under very precise conditions. So under lightning conditions, basically. So it would need the exact same composition of material also to be identical to the one found outside. The sample they tried to generate also broke down into another material because they were heating it up for too long. So, you've got to get it, like I said, it's got to be lightning strike conditions. So it's believed that other new minerals may be found in the future by studying more fulgurites, which is pretty cool, I think.
Yeah.
So for those, especially I used to collect rocks when I was little. That's just one of my
You did, that's right,
secret
yeah.
nerdy things. So I had lots of different minerals and I used to be amazed by the structure of them, their colors and all of that. And then when I started chemistry, I was more amazed by them because I learnt about atomic structure and molecular bonding and all of that kind of thing. So I thought that was really cool. And I looked at my minerals in a completely different way. So I can imagine why people studying minerals would be so excited to find something new and something that may be like just so so rare on Earth. Who knows if there's another one like this?
Yeah, I was going to say this could be the only sample or one of the only samples of this particular mineral because of, like you said, the very specific conditions that were needed to make it, which is really amazing.
That's right.
Yeah,
exactly. So that's so I thought that was pretty cool. I found some interesting facts about fulgurites just to further our knowledge a little bit more. So the name fulgurite actually comes from the Latin fulgur, which means lightning. Fulgurites need a temperature of about 1800 degrees Celsius to form, and most lightning strikes are about 2500 degrees Celsius. The largest fulgurite ever found was in South Florida, so the same kind of area, and measures about 4.9 meters or 16 feet in length. So that's a huge one.
That's a huge
Imagine that
one.
lightning. I don't want to be near that lightning.
Oh, wow.
They've been found up to a depth of 15 meters or 49 feet below the surface. And since they're created by lightning, studying them in a specific area can also help to understand the climate and frequency of lightning strikes in the area, which is another interesting area of study concerning fulgurites. And they also provide a fossilized record about the number of lightning strikes that have occurred in the past. And if a lightning strike has multiple forks, sometimes they form multiple fulgurites in the same area. So that's really cool as well.
Yeah.
Yep.
So there you go. There's just a very brief rundown about fulgurites. So I thought that was interesting. I needed to share that.
That's fascinating. I like that. I was just Googling while you were talking, just pictures of them. And like you said, the shape is unique. And some of them are long and have different shapes. And, you were talking about that. That's amazing. And just to think about, so if they wanted to recreate one, they would need to somehow, mimic a lightning strike that was 2,500 degrees. Yeah. Which
Goodness
I don't know how you
me.
do that.
That's it. And if they, like it mentioned in the article, if they get it too hot, the mineral changes into something else completely.
Yes.
Because, the bonding happens at particular temperatures, particular pressures. If you've done chemistry before, you understand how, temperature and pressure is very important. You also need the right amount of the particular elements or molecules or the substance to create that particular mineral. So everything's precise. For example, diamonds need a particular pressure and particular temperature to form. They're made out of carbon. Carbon under one situation may be coal, but on another situation it's a diamond. So it's got to be under the correct pressure and temperature and the right conditions. Yeah.
Do you
Can I
think
ask you a question, Caroline?
You go, Lino. Yeah.
Oh,
Yeah.
Sorry. When you're talking about diamonds, is it that? What is the difference between the carats? Is that how many?
The carats of diamonds. That's a good question.
Oh, sorry,
I'm not
putting
really
a spot
sure.
there. Okay.
I mean, I'm not a diamond expert. I just know
okay.
that there's particular facets, the way they're cut and all of that, the clarity. I think it's got to be like a perfect diamond, and then it's judged on how many carats it is. So I think it's got to be
So
how
it has
perfect
to do with
it is. Some diamonds are manufactured, yes, but some
also,
are. I think
also
the
weight
more
of the
precious
diamonds
ones are
from
found
what I
in
can
nature.
see here.
The weight, yeah.
Yeah.
But the more precious
okay.
ones are found are the ones naturally found. And if you've got like even the color of diamonds, you can have yellow, pink diamonds, you know, you can have, so I know a bit more than I thought. So, you know, so, yeah, the rarity of that particular diamond, you know, that's how it makes more, how you can determine how more precious or valuable and the carats and all of that. So, yeah. But if anyone's more of an expert on diamonds, please feel to,
jump in, tell us,
to make some comments.
Chuck it on Discord. Come on. Yeah.
Yes, yeah.
I don't know if it's a question more than a comment, but I'm trying to understand how this process of fulgurite being created. So is it, you know, you were talking about the specific conditions. Do you think it's also, do you think it's instantaneous because a lightning strike is so quick, right? So is it just like within the time it takes for a lightning strike to, you know, occur and dissipate, that's it? The formation's already happened?
It's done. It's basically done because it may take time to cool down, perhaps, and the crystals need to cool down. And so like if it's a fast cooling down, you'll have smaller crystals. If it slows down, if the cooling of the substance is a bit slow, you'll have larger crystals. But definitely when the lightning hits the material, it will automatically bond whatever's there together, you know, and you know, you have to go into molecular structure and all that, but it would all kind of stick together in a particular way, and the atoms will be aligned in a particular way, and to form this new mineral, the calcium phosphate that we haven't seen before. But definitely it's an instantaneous reaction. But like I said, the time to cool down may also have an influence on the structure and the crystals in the particular material.
Very cool.
Is some lightning? I don't know where we got taught this or where I heard about it, but does lightning come from above and below and hit together and make that crack, or do they actually come down from above and down? And that's it.
So, as far as I know, it's created in the atmosphere and it will come from above.
Okay. Not from
like
below
a static,
as well.
to do with like a static charge.
Yeah, but it may come
yeah.
from below. You're right. So if there is a particular situation that will invite it from the ground, perhaps there is that.
Okay.
I'm not an expert in lightning.
Oh, no.
But
I was wondering.
now you've given me something to think about, which is yeah. But it is started with atmospheric conditions. Yeah. So it just creates a charge and then boom, there's a lightning. Yeah.
Wow.
Yeah. Just other brief science news, if I can just change topic very quickly now.
Oh,
so,
of course. Go for it.
Yes. All right. So you know what I'm talking about. So a couple of nights ago, we've been waiting maybe 2 years for this now. So the first launch of the most powerful rocket in the world, Starship, you know, on the Super Heavy booster. So the first test launch occurred, so at time of recording, it would be a couple of days ago. By the time this episode comes out, it'll be almost, just over a week. But essentially, SpaceX has been working on a new type of rocket. So it's still very experimental, but it is the largest booster and most powerful booster in the world in order to lift the second stage, which they call Starship. And so at the moment, I think a Falcon 9 rocket, so Falcon 9 is the rocket that launches the most every year now. And that can lift about, I think it's, is it 15 tons to orbit? I think it is something along those lines. So so when Starship / Super Heavy is eventually ready, the aim is that it would be over 120 tons to Earth's orbit and beyond as well. So, if anyone watched it, so it was at 11:30 at night, I stayed up to watch this, right? So, this test was most likely going to fail. Like, it's not a surprise that it failed at some point, because again, this is experimental technology. If you've seen how SpaceX tests rockets, if you saw for example, with the Falcon 9 tests, there were a lot of explosions, a lot of crashes, a lot of,
Yes, it's kind of, I mean, you don't want them to be exploding, but it's kind of cool when they did.
Yeah, that's right. And that's the particular way that SpaceX operates, which is why you see more test launches and more explosions. Whereas if you see NASA's Artemis 1, this was more about, it's got to be perfect the first time. So that's why there were several launch attempts. That's why it took years and years and years and years for this rocket to take off, because it had to be successful. And because it's a government program, so you've got to show results, right? So if you've got an
That's
explosion,
exactly
no
right.
money,
It's a government thing, and they probably don't have unlimited money like SpaceX would have, whatever Elon wants to put into it.
Yeah. So whereas SpaceX, they talk about iterating, upwards, so you have a failure, you learn from it, you do better next time. So this current version that launched, it cleared the pad, which was one milestone. So getting off the ground is the first thing, right? Which is really good. It made it through max Q, which is the time where there's the most aerodynamic pressure on the rocket. So it got through that, and it got to the point. So it was got to about 38 kilometers above the Earth. So they did show one brief bit of footage where you could see the curvature of the Earth, from space. The actual space technically is considered 100 kilometers above the Earth, so they call it the Kármán line, I think. So it didn't quite get that far. It did its little flip so that the second stage could separate.
But then
there was no separation. So because the first and second stage were still connected, it kind of started to do some aerobatics and spin out of control. Yeah. And at one point,
did you notice that there were about probably 6 engines that were not lit up?
Yes.
So that might have had something to do with it as well. Yeah. I don't know. But
I wonder if some of them might have been damaged by debris at launch, because if you look at the orbital launch pad now, there's a massive crater underneath it. From the power of these 33 engines, all going off at once.
Then they need to sort that out as well.
So Elon Musk tweeted, Elon Musk tweeted, okay, maybe we do need a flame diverter, because a lot of these large rockets, if you look at, for example, the launches of other rockets, and especially go back to the NASA space shuttles, for example, they have a flame diverter system so that the power of the engine, the flames go down to the ground, and then it kind of diverted outwards to the side, so that you don't have all this sort of blowback on the rocket, and all this debris and everything flying back in. So
that's right. It's all
there were
learning,
chunks of
isn't it?
concrete. Yeah, there was NASA Spaceflight is one of the media organizations that loves, they're just enthusiasts who love to cover all of this. And they had a car that was several kilometers away, but closer than most others. And it got hit by rocks and debris and got smashed or whatever.
I was about to say, that's a bit close, yeah.
But the thing is, I'm pretty sure they were expecting it as well. Anything.
Of course.
So they knew what risks they were taking.
They would have been prepared for that.
Yeah. Yeah. So anyway, so very cool.
That was great to watch.
Yeah. So I think it was about 3 or 4 minutes into flight, they activated. It's called the flight termination system, which is where they basically explode the rocket because it's gone out of control, and that's for safety reasons. So a very good start. Obviously, they've learned a lot. What people also need to realize as well is that the technology on this particular booster and second stage Starship is not the latest technology that they currently have. So it's the technology they had at a particular stage. They've already improved because there are already other boosters and Starships that have been built, right? That already have improved technology. And this is how SpaceX always works: is they launch with a particular what they have. They've learned from that, but they're always iterating upwards until they have the perfect design. Because what they're aiming for is to have a 100% reusable rocket, which doesn't exist yet. That is not a thing yet that anyone can do. So right now they can reuse their boosters on their Falcon 9s, but the second stage is disposable. So they want a 100% reusable rocket, and that's what they're aiming for, which is very ambitious.
It is. They basically want space travel to be something like you just take a bus and you're off to the moon and you're off to Mars, and then you come back,
Or you're off to another country as well. I mean, eventually, and this is still years away.
Yeah, that would be great.
you could just about seriously catch a rocket and almost not instantaneously, but within a very, very short amount of time, within an hour or less, you could be in another country. So
I know. Yeah. Wouldn't that be good for us going to Malta? We can't go because it's such a long flight and so expensive. But imagine if it was just a short flight, just a short rocket launch away.
Yeah. Although I'd say if we go to Malta, you'd have to land at sea because there'd be nowhere for a rocket to land on Malta. Yeah.
That's right. Or you land on a bigger country and take a plane from there. It would still cut down the time.
Yeah.
Cool.
Yeah.
Oh, wow.
Good one. All right, exciting stuff.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest Show Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest. Here's another show on the StarQuest network you're sure to enjoy, The Secrets of Middle-earth. Find it wherever you can find podcasts or at sqpn.com/Middle-earth.